Hi, good day. This is once again Teacher Rika, your math teacher. Today we will talk about polynomials. Last time we talked about algebraic expressions. Now, polynomials are algebraic expressions, but why are they special from the other algebraic expression? So, a polynomial is an algebraic expression involving only addition and multiplication of numbers and variables. Examples of polynomials are 5y squared, a cubed minus 1, p to the fourth over 5 plus 7. And non-polynomials are 5 over y squared, 2 over a cubed minus 1, and 5 over p to the fourth plus 7. Now, why are these non-polynomials? Because of the variable in the denominator. So take note, when you see a variable on the denominator, it is not a polynomial anymore. A single-term polynomial can be called a monomial, and a two-term polynomial can be called a binomial. So last time we talked about terms. So terms are parts of an algebraic expression separated by plus or minus. What are examples of monomials? We have d squared, negative mno cubed, 16x squared y to the fourth, and negative a squared over 5. What are examples of binomials? D squared minus 4, 5m minus mno cubed, 16x squared y to the fourth plus x cubed y to the fifth, and negative a squared over 5 plus 16. So why are they called binomials? Because it has two terms. The first one, we have the terms d squared minus 4. The second one are the terms 5m and negative mno cubed. The third one are the terms 16x squared y to the fourth and x cubed y to the fifth. And the last one contains the terms negative a squared over 5 and 16. Now, there's an example of a binomial 9w squared minus 9y cubed, wherein if we will factor out 9, it becomes a monomial. So this is a single term polynomial. When we factor out 9, it becomes a monomial. A three-term polynomial is also called a trinomial. For example, v squared minus 3v cubed plus 1, which contains the terms v squared, negative 3v cubed, and 1. A constant is a single-term polynomial. So if we say constant, it's a term with no variable. For example, 25. The degree of a one-variable polynomial is the highest exponent the variable has. For example, if we're given 6a to the fourth minus a to the seventh plus 1 plus a, there are four terms. What are those terms? 6a to the fourth, negative a to the seventh, 1, and the term a. What's the degree? It's 7. It's the highest exponent that you can see among the variables. Negative 11x cubed plus 5x to the fourth minus 3x to the sixth. How many terms are there? There are 3. What are those terms? Negative 11x cubed, 5x to the fourth, and negative 3x to the sixth. And the degree is the highest exponent that we see among the variables, which is 6. How about next 17b to the fourth? There's a single term, one term only, and the degree is 4. So that's the exponent of our variable. And negative 21, there's only one term with a degree of 0 because it's a constant. 0 as a polynomial has no definite degree. Now let's practice. Determine if the algebraic expression is polynomial or not. So we have here two boxes given the following polynomials. If we're given 15c squared minus c plus 5, where does it belong? So it's a polynomial. How about b squared plus 4b over 3? It's a polynomial also. 8x squared over y squared plus x over 2. So it's not polynomial. And 100, that's a polynomial, which is a constant polynomial. And a cubed minus 3a plus a squared all over y is non-polynomial. Why are these two algebraic expressions are not polynomials? Because of the variable in the denominator. Okay, so let's have some practice. Given the following polynomials, let's determine the number of terms and the degree. 25 plus d squared minus 6d cubed plus 2d to the fourth. How many terms are there? If you got 4, that's correct. And the degree? 4 also. So what are the terms here? 25 d squared, negative 6d cubed, and 2d to the fourth. And the degree, that's the highest exponent that you see on d. Number of terms of a squared plus a to the fifth minus a to the seventh all over 9. There are 3 terms. What are those terms? We have a squared over 9, a to the fifth over 9, and negative a to the seventh over 9. So what's the degree? That's 7, the highest exponent of a. 14x minus 13, how many terms are there? There are 2. The terms 14x and negative 13. And what's the degree? That's 1, which is the exponent of x, which is invisible. 5/4 g to the 6th plus g to the 10th minus 2g all over 3. How many terms are there? There are 3. 5/4 g to the 6th, g to the 10th over 3, and negative 2g over 3. And what's the degree? That is 10, the highest exponent of g. Okay, so let's have some exercise determining if the algebraic expression is a polynomial or not. If it's a polynomial, tell the number of terms and the degree. So if you wanted to answer this exercise, you can pause the video. That ends our lesson about polynomial, its introduction. So I hope that you're following all of our videos or all of the videos I made because they are interconnected. And don't forget to subscribe to get notified for the next videos. Thank you and see you for the next lesson.